off yesterday, and we are going to get this chapter finished up. We're going to start chapter 18. So once again, I went to the notes and I tried to line the notes up so that they just strictly follow your textbook as you'd be reading your textbook. So that's why I've given you the first 24 slides out of chapter 18, because I didn't have it up until this morning. Okay? So the rest of the slides, of course, are there now if you want to look at chapter 18. If you printed off the former one, I'm sorry. Okay? I did go in and revise the entire chapter so that it would match your textbook. Okay, so let's finish up chapter 17, the endocrine system. And definitely has been a fun chapter talking about hormones, these little chemical signals that are flying around in the body. And we left off yesterday talking about how these chemicals have certain properties, that there are these defining factors that are going to be present for all of these chemicals. And one of the things that we've talked about is how they're either lipid soluble or water soluble, and then if they're one or the other, their mode of action once they get to the cell. And we left off yesterday, we had looked at how those hormones can travel in the bloodstream. And if you remember, they could travel, that looked like a finger. And I was like, oh, never mind. Okay, so how they could travel as being either free or bound. Okay? And then once they make it to their target tissue, and I tried to remind you that the target tissue could be the cell itself, it could be cells in the same region right there, or it could be a cell of a different type at a distance. All right? So when we get to the target tissue, we're going to find that there is a receptor, and depending on water soluble or lipid soluble, we can have the receptor on the membrane, or do you guys remember nuclear receptors? Okay, but either way, that receptor is specific. Okay, the shape of that receptor is only going to accept the molecule that will fit into it. And if you remember, one of the things that we mentioned, these chemicals, these hormones, we only have to produce them in a very small amount, because once they get to their target tissue, they get amplified for their response. Okay? So binding sites are going to be very specific, because some of those hormones are extremely specific. For example, we mentioned glucagon. Glucagon, what tissue does that go and act upon in the body? Do you remember? Huh, what? The liver. So we don't want receptors for glucagon in all the other tissues of the body. We only want it to be there in the liver. Does that make sense? So the tissues can be very specific, and then the receptor itself is very specific. So, believe it or not, the cells of the targets can control the hormone usage by way of their receptors. It's called either up regulation or down regulation. if we think about controlling it based upon the receptors, upregulation is simply saying increase the number of receptors. So if we increase the number of receptors, this cell right here had just a few. It said, whoa, wait a minute. I think I need some more of that chemical. So let me increase my receptors so I can get more of that chemical, and then I can have more of a response. So the cell controlled its usage of the hormone by increasing the number of receptors. Can you think of a time that this could happen?
If you were pregnant?
Okay, some areas of the body might need more of the hormones. Good example. Do you guys remember luteinizing hormone? One of the gonadotropins? What'll happen during the menstrual period? Females, we're the ones who have the ovaries, all right? The ovaries are going to need to increase their sensitivity to the luteinizing hormone. And so what they'll do is they'll use upregulation, get more of that luteinizing hormone, and therefore that will help with the release of the egg. Then, once it's released, receptor number will go down.
And it just sheds the receptors?
They can just die off and be reconsumed, taken up by the body. So, down regulation wants to decrease the numbers of those receptors. So if we have a cell that has a lot of them, the cell is like, wait a minute, I don't need this much chemical. And it will decrease the number of those receptors, makes it less sensitive to the hormones, and therefore decreases the taking in of that chemical. This is what could happen with a long-term exposure to a hormone. A good example of this is one of the things that's going to happen with the hypothalamus. The hypothalamus is going to have this pulsed release of gonadotropin releasing hormone. So it doesn't ever completely come to a full stop, and it doesn't ever completely stay up high. There's a constant pulsing of the release of that hormone. And so what will happen is that pituitary gland will become less sensitive to that gonadotropin releasing hormone from the hypothalamus, because it's just this constant exposure, but it doesn't need to have a constant output of these hormones, FSH, LH, okay? It needs to have a control. So it'll just reduce the receptors and therefore control the release of the hormones. Kind of looking at me crazy.
Yeah, that's
all right.
sorry.
No,
I mean, because
that's
it's
okay.
it's constantly being released, no matter what.
Well, it's a pulsing. Like, in other words, it doesn't ever come to a stop. So there's always something being released from that hypothalamus for that gonadotropin releasing. Isaiah? Okay, so my hypothalamus, right? Then I got my little pituitary gland hanging off, okay? So if the hypothalamus is constantly sending the gonadotropin releasing hormone to my anterior anterior pituitary. And if that would force the anterior pituitary to constantly release FSH or LH, for example. Now, remember what those are for. Those are for follicle stimulating, luteinizing. They're going to the ovaries, testes, right? For example, in a female, do we need that to be constantly sent to the female? No.
No, you said for ovulation.
Right. So it would be like one time a month that this would really get produced. Okay? And males pretty much constant. Okay, for that one. But for females, we're looking at a controlled amount. So the cells in the anterior pituitary will decrease receptors for this one, the GnRH, so they don't produce as much. It'll have a control over the release of that hormone from the anterior pituitary. Does that help?
Yes.
Is this sort of like what happens during like puberty or something? All the hormones and makes everybody crazy, and then eventually it releases the receptors.
I'm gonna go with yeah on that one. Mainly because at that time frame of life, for example, one of the hormones that's gonna be in a huge amount of production is growth hormone, okay? We'll begin to see estrogens come about, androgens, that sort of thing. So yeah, you have surges of these hormones, and that's about the time frame we lose our brain cells. We get them back a little bit in our late 20s. We gather a little more of those lost brain cells in our 30s. By the time we're 50, we have them back. We just don't remember what they're used for. So, those hormones definitely mess you up. Yeah. So, the cell can actually control how much of that chemical it's going to be sensitive or not sensitive to.